everybody, we're finally back. Got something kind of interesting here to show you today. I've been working on this for probably about 3 years, adding refinements when I seen that there was something else I could add that would improve. What you're looking at is the total control module that takes care of step start, the time delay on holding transformers on during your transmit cycle, and then shutting them off when you're not using them or not talking. It actually watches and waits for you to, in between intervals of talking, like if you get up and go get a cup of coffee or something and you're away for 3 or 4 minutes, it'll just shut the transformers off. Helps keep them cool, uses less energy that way. Plus, it also incorporates a warm-up timer that keeps everything on hold until like the filaments of a big tube get warmed up. Tubes like this data sheet says a minimum of 190 seconds before you actually operate the tube. The timer that I have that ends up about 3 minutes. The timer here is set for about 5, because that same timer is also used for your fan cool down cycle. When you go to switch the unit off, the action of turning the filaments off to the tube, that same switch activates the hold timer that allows the power supply to turn off, but it keeps the fan running and everything else live so that the tube can cool down up to about 5 minutes, and then it just shuts off and everything goes dormant and quiet. Warm up, the same circuit's used. The on switch initiates the initial trigger and the wait timer isn't activated, and that holds the standby circuit in standby mode. Doesn't allow you to key up. This module will, however, while you're waiting for like this would be in the driver amp, it allows you to key up your downstream amp to tune it if you want, or talk through your driver amp. It allows the PTT line to activate while you're waiting for the tube filaments to warm up. And when the time runs out, the light that you would have on your standby operate switch just simply turns to green and you're ready to go. So now we'll try to activate this circuit. Now, it automatically activates the hold timer as soon as power is applied, so I'll have to actually dump that energy out of that. I see we haven't got I forgot to hook the power supply up. Okay. So we'll hook it up. And if we try to key up, let's see if it's all working. Yeah. You hear the relay. All that's doing is activating the relay that would, if it was in the unit, it would activate the PTT line for your other box. So we could dump that now. I'm just going to simply discharge the cap. Okay. And now if you was to key up, this little thumb button switch here assimilates your electric keying circuit. I have the hold or delay turned off so that you can see the sequencing, because once you key up, it'll latch these two relays and hold them to keep your power supply turned on. But I've turned that off just for a bit so you can see the sequencing, and I'll run this through the cycle several times so you can, and it's slowed down. It's actually about half speed so that your eyes can catch the sequence. The antenna relay always keys first. Pre-charge, this relay activates and turns on like if your power supply was a 240 volt power supply. This relay applies neutral and line 1 for just a short duration of time to the power transformer, giving the 100 or 240 volt transformer actually only 120 volts or half voltage. So it eliminates the step start timer, and you don't have to use a resistor and all that nonsense. It's just simply 120 volts to a 240 transformer that's half voltage. Get your power supplies charged up, your caps charged to about half voltage before line 1 and line 2 come on. See, it only stays down for just a short time. This relay and this relay operate on the same relay on the board. This relay is turned on in the initial cycle, but as soon as that relay activates, because you don't want your line 1 and neutral tied to the transformer when line 1 actually connects up. So you see it releases it. This one releases before this one connects. Okay, move on down the line. This hooks up line 1 to your power transformer of the 240. And this one hooks up line 2. So one side of the transformer is hooked up, and then the other side is hooked up. So you don't get no arcs anywhere. Finally, all the way down here, you see the last relay to key up is the screen relay. So antenna, the power supply, and then the screen. No matter how you quick key it, the screen always waits, because the screen relay is operated after this relay here closes. So it waits for this relay to close, and then there's a time delay actually between this relay closing and the screen. So it gives your high voltage that split second to come up to full voltage. Now we'll turn the hold on, and I'll show you what happens. We'd have to be waiting a couple minutes between keys if we actually wanted to watch these relays run and cycle down. So that's why I've added just a switch temporarily to shut them off. But now when I key up, this relay is going to key. This will key just like normal, but these two will hold and stay keyed when you unkey. See your antenna relay? Keys first, then the screen. This is what you'd hear in normal talking, like if you was in a conversation and keying up before your timeout cycle timed out and turned the power supplies off, and you're waiting for the guy to respond. It'll hold your power supply on for about 2 minutes is how I've got the timer set. Roughly 2 minutes in between key ups. So it gives the other guy time to talk and do his blah 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 blah. Now, at the sacrifice of about 2 minutes of time here, roughly, we'll just wait, and you'll see what I mean. These two will just turn off. This is like, okay, I'm done talking for a second, I need to go up and take a bathroom break, or it's time for a cup of coffee, go grab a cold beer out of the fridge. And you see it's waiting. Your high voltage is still on. but when the time runs out, it'll actually turn your high voltage transformers off. So if you have fans on them, you actually can cool down and save energy in between talking if you're waiting for maybe the skip to come back in, or somebody else is covering the guy up and you want to wait, or you're just standing by waiting to talk to the next guy. See, it's a long time. But in a bit, these will relax all by themselves. Like I say, roughly 2 minutes. 2 minutes seems like forever when you're waiting for it. There you go. Now your power supply is turned off. Your transformers can start to cool down. Your high voltage is floating back to zero. It's waiting for you to key up. The next time you key up, step start will take it right back up to where it was. Everything goes back to working. There's no microprocessors. There's no RF sensitive devices. I'll go through that here in a minute. It's all good high power transistors. Some are Darlingtons, and they all have a very high collector voltage, so they can be in a pretty RF intense environment, and you should not have any problems at all. They're all good heavy stuff. Okay, now we'll simulate keying up, and we'll go right back to work and talking. That's how it works. Okay, now we'll talk about the mechanics. Luckily I've got a little remote here on my camera, and I can kind of see what it's viewing, because right where the camera's mounted, it does not have a display on it. So we'll take this out of the way. We'll turn that off, and we'll talk about this module, how it's built, how it's wired up. Okay, let's see my field of view here. Come on. Okay. I might need to zoom out just a little bit. Yeah, the bad thing about it is it doesn't give me this little remote wants to shut the screen down, so it takes me a minute to see what I actually can see there. Okay. The circuits. All these are numbered, and you'd get this schematic with your unit. These are all the contacts on the sides of the unit. I've got another one here that is ready to go into. Oop, come on, lights. Hang on there. This is what you're looking at. All the numbers are on there. And there's the unit. Okay. Starting with the first keying relay. This relay right here, all these are 24 volt. This outlet would go out to the collector of your keying transistor. Standard keying transistor, NPN, emitter hooked to ground. The collector would be tied to this pin. and your standard on the other side would be your pair of voltage doubling diodes, like 1N41/48, the typical 10 puff sampling cap, maybe a 2K resistor in between the positive and the base of the transistor for your sideband, and you of course short that out for AM. Okay, the next, when this relay closes, this goes out to your standby operate switch on the front panel. That comes back in, hooks to the next relay, which activates everything. You have transmit and receive. There's a green light that comes off of this one here, or the wait LED. Then you get the ready light, and you get a receive LED that's on this relay right here, relay 5. You got a green light, and you could hook that to a green light if you was going to use that. The timer and hold circuit is this one right here. This holds this relay closed. I gotta find them. Here we go. This relay here. So I get on the right one. This is your warm up and cool down timer relay. It holds this one closed, and you've got a wait light, which would be like a red light on the front panel. And it's going to hold that there for the 5 minutes that it takes for your filaments to warm up. When this times out, it just simply relaxes. The relay goes up to here. You end up with a green light, a ready light. I use bicolor LEDs, so this actually would go to one lead of the LED, and this would go to the other. So it would go from red to green when it's ready. You can do it any way you want. It could be separate lights, whatever. Okay, that activates or makes available your operate voltage that you can use on your standby switch to activate other relays. It also turns on and activates these all by itself, so that when you're waiting, you can actually key and it turns all this off to where none of this will operate on when you're waiting. Or for the cool down cycle, it also holds it turned off on the cool cycle. The initializing circuit that either starts this to run for the warm up cycle to hold, or the fan cool down cycle, is these two little caps right here. And we'll get into that. I've got them. Okay, I'm getting out of order here. What I'll talk about first is the standard timer circuit. We'll get to that timer. We'll do the that startup cool down thing in a minute, because I'm getting out of order. Okay, basic timer building block. A cap paralleled with a resistor, and a resistor in series with the voltage coming in that activates it. So if this cap is discharged, there's voltage applied here when you want this circuit to work. This resistor slows down the time it takes to charge this cap before it can turn this resistor on. In other words, this cap holds enough of a current that it doesn't allow the transistor to key or conduct until the voltage reaches the threshold of the transistor. So this resistor is to discharge this cap when this transistor is not being used. So it keeps it ready, it keeps the cap discharged. This resistor is part of the timing circuit. The cap holds off the transistor from closing or conducting to close the relay. And that's your standard building block. That is used on the first transistor timer that does the pre-charge, and then the next one runs the line 1, line 2 relay, and this one here runs the screen timer. So all of these are set in sequence, and some of them actually don't get activated, like this one, where I was telling you that the line 2 relay, when this closes, the power actually comes down here and then activates the screen relay. So the screen actually has to wait until the power supply is up and running. Okay, now this circuit explained. This is the warm-up, cool-down timer. Same thing here. You got a cap holding at 0. You got a resistor that keeps this discharged. Now this is a little bit different because we needed a longer time. So the value of this resistor is fairly high, so that it takes quite a while for this cap to discharge, because we're actually charging this cap and using the voltage stored in this cap to keep these two transistors keyed. This is a Darlington, but the transistor I use here is actually a Darlington in its own right, but it needed a little more sensitivity to get the time needed, so I didn't have to use a timer circuit, an actual high-priced timer module. It was simpler and cheaper just to build them out of a 25-cent transistor. I think this one's about 75 or $1. You got a 35 or 50-cent cap, a 3-cent resistor, relay about 50 cents, and this relay is about $1 a piece. It's a 10-amp relay is what I use. So what initiates this is you have a voltage come in here that charges this cap. This voltage can go away, but this cap now is charged, so it's going to hold these relays active until the charge dissipates out of this capacitor. And this resistor is your timer again to, like I say, discharge the cap. There's a resistor here. It adds in timing, because if you just feed a little bit of voltage to that transistor, it'll keep it activated or conducting. If I went lower with this resistor, like if you wanted to speed the time up, you could actually change this down to like a 75K, 47K. You could experiment with that. Common 2N4401 there, and this I'm just using them because one time it was before a company out of Seattle went out of business. They were called Radar Electronics. I bought a big almost a gallon jug of these things. There must have been 2,000 or 3,000 of those transistors. They're just a little tab transistor, but they'll handle 2 amps on the collector, I think about 100 volts or something, maybe 160. So they're a good high voltage, and they are a Darlington, an MJE 800. Okay, now how this one is activated, that's a little trick that I had to come up with. Okay, we have a couple diodes here. We have caps in series this time with a relay. Now this is a sensitive relay. I've got one here I can show you. Sensitive relay. It has a very high resistance on the coil. This one here I think is in the neighborhood of 2,400 ohms. So it doesn't take much current to keep this relay closed. And again, it's a 24 volt. So just by virtue of the 24 volts going through here, going into that relay coil and going to ground, the current across that cap that it takes to charge that cap actually closes the relay. When the cap charges, reaches full charge or equalization, the relay just unkeys. It's a pretty interesting trick. If you try it, you'll see what I mean. You apply voltage, the cap will charge. During the time it's charging, the relay closes. But as soon as the cap is charged, the relay relaxes. This resistor is there simply to discharge that cap when it's not in use, so it's ready for the next cycle. Same here. One of these is for the shutdown cycle. It's operated, you would make your connection to your filament on and off switch. You'd use a double pole, double throw. One half of that switch would turn the AC on to either a relay or your primary of your filament transformer. The other half of that switch would go to 24 volts on the center, your common of that switch, and when you switch it to the off position, it would apply 24 volts to this line, then activating this relay. This circuit right here, this cap and resistor, activates when the 24 volt power supply is first turned on. Like when you turn the power switch on to your amp, power is supplied to the 24 volt circuit. For the relays, the key in circuit, everything, that 24 volts comes here, charges this cap, closes this relay for that period of time. 24 volts then goes from here out to the warm-up cool-down timer. In other words, from this line here, we're actually connecting to this line right here to activate the timer circuit to that. That's how that gets activated. Okay, now this unit would be used. I'll give you kind of an example of how you would. Oh, I'm going to turn my lights off if I don't watch it here. Oh, come on. Hang with me. I've got it kind of Rube Goldberg until I get them all tied up. I wanted to get this video done while it was quiet today. Let me make sure that we're still in focus and I've got this page in the right spot. So one thing about this little remote, it has to wake up. Yeah, I thought so. Okay. I'm going to have to review the video and make sure that everything was in frame. I can. No, let's go this way. Give as big a view as possible. Okay. This would be that module that we're talking about right here. And the numbers, number 22, number 21, 24, all of these are these numbers here. There's 24, 22, 23. It's using all those connections. That's what we're talking about. Okay, so 24 volts, this would be an example of your power supply that would supply 24 volts to the controller. And then you see another line here, it runs down. This is that switch that would be part of your filament on and off switch, like one half of your filament on and off switch. And this is how you'd hook it up. One side of that switch, like I say, would go to the primary. On this particular one, it's hooked to a relay, and that relay could go to the primary. Like if you got a big tube and you need a high current switch, well, you could use a relay for that. So that's where this line goes out, and this, for this particular amp that this was going in, we actually used a relay to turn the filament transformer on and off. And it was 24 volts, so we actually didn't have to use a double pole, double throw switch. We was actually able to get away with a single pole, double throw. So this turns the filament on, and if we wanted to turn the filament off for cool down, this switch then would move to here. That activates that circuit I was just showing you, that activates and charges those caps, holds the relay closed, starts the fan timer. And since we've moved this switch to turn the filaments off, now the tube can cool down, but yet the circuit will hold the power supply on. And how it does that is we have an outlet that comes out of the controller, goes through a diode, and it runs a relay that keeps your power supply transformer running This also runs the fan, is also tied to that, and this is usually a 10 amp relay to turn your, this is actually the key-in circuit, and it's also the bias transformer for the tube. So we're getting bias and our 24 volts all from the same transformer. Every build is probably going to be different. It just depends on what transformer you get, but the general idea will be what you see here. If it's a different transformer, it doesn't really matter what this circuit is, we're still going to be using the primary of that transformer. So it's pretty much going to be the same. It's just each transformer may get a different power supply hooked to it, but that's the general idea. Same thing here, no matter what this transformer is, this would still work in the same way. This relay simply keeps power on. We have a fuse to protect everything. It also, the fuse is in line, also runs if there's a problem in the transformer, we get the fuse for that. The fuse also is down here. This is a little tiny 25 milliamp transformer that I use as the start. I call it the start transformer. And your on-off switch is only turning that transformer on. What it does, it creates enough voltage to close this relay. That's the only thing this transformer is doing. This is a diode. We got cap to ground. This diode simply keeps whatever's going on. If we got something else tied here, just depends on how everything's being used. These diodes simply stop power from going backwards, causing something else to operate that we wouldn't want working or running. So it just makes sure that the power goes one direction. It's not for rectification. This one is your rectifier. This one simply keeps the 24 volts going toward the relay. And since it's going to the relay, we don't need it coming back in here. Like I say, in case something else is tied on this, you wouldn't want it kept activated when we're trying to turn the unit off. So we have, I guess you'd call them steering diodes. That's all they're for. But that's the general idea, and that's how the timer would be implemented. Obviously, there's more outlets coming off of this. That is your antenna relay, your step start relays, etc. Is coming off of this. But this is mainly your warm up and cool down cycle on that. Okay. Next, if you'd like to contact me and you'd like those schematics, I haven't got them all set up in an email yet, but I will do that. We got I guess he's going to see the neighbor. Sounds like a Harley. Well, I'm not sure what's going on. My little remote doesn't want to come back on, but I hope that's in focus. I don't know what's going on here. Huh. Anyhow, hope you can see that. There's my email address. I'm going to assume that's in focus. RadioMedic111@yahoo.com. And my mailing address, should you want to talk to me by snail mail. Yeah, I see the red light still on the camera. I'm going to assume it's still recording. I don't know what the deal's going on. Don't you just love technology? Anyhow, I guess that wraps it up for this time, guys. And got some announcements coming, some builds coming up. If you can see them here. Got a tube here. We're going to do a build with this. Is a GS23B. Going to do a build video on that. And we have another heavy hitter, 1500 watt tube. This is actually the tube that prompted having to have a filament timer. This tube actually says it needs a minimum of 190 seconds. The minimum of a little over 3 minutes to warm up. But that'll do about 1100 to 1500 watts output. And we'll be doing a build on that here coming up shortly. Okay, I'm going to shut this off. I see the camera is still showing a red light on record. So I'll have to manually turn it off. Take care, guys. We'll be talking to you. I got more announcements coming about some of the builds and what we're going to be doing in another video. So goodbye for now, and see you on the next one. Okay, camera's cooperating with me. I wanted to throw this in there just at the last, just in case anybody has never figured this out. I made this discovery, I think it was actually Otis that told me about these, and I'd never had a chance to try it. Just remembered what he said, filed it away in the back of my head, and thought, well, I'll use that information someday. Well, I got some of these relays from a swap meet, $5 a piece. They're a 120 volt relay. Otis says that these relays will work just fine on 24 volt DC. So I've got my 24 volt power supply. We're going to do that right now. Really interesting. These clackers. Gotta make sure, yeah. Okay, we can see it. Alright. Here we go. 24 volts. Look at that. 24 volts on a 120 volt relay. They're made for 120 volts AC, but they work just fine on 24 volt. Look at that. So, don't pass them up if you see them for good price, because they'll work just fine. Let me see if I can get this thing to where it'll hold really good. I'm going to show you. It actually has quite a bit of strength in pulling down. It's latched. There. It takes a lot of pull to pull it off of from being closed. It's tight. So it's got a lot of pull on them paddles. Not sure if you can see that on the camera. My remote will bear with me here. Come on. There we go. Oh, come on, stop it. Can you read that? Get it up. Come on, stop. There we go. 120 volt. They're 25 amp relay, but 24 volts will operate them. Okay, that's it. I just wanted to add this in there when I knew the camera was working. Just had to cycle it off and back on, and everything came back. So, all right, guys. Talk to you later. See you on the next one.